Good evening, everyone. Switch on your cams. Let's start off. Yeah, cams on, everyone. So last class we did that aeroplane problem. Did everyone got the answer for that aeroplane thing? RKC? Any answers on that?
Shall be equal to R.
It will be equal to R, right?
Nah, it won't be R. Why it will be R? I know what you did. Are you guys thinking that this will be 60 degrees? That won't be 60 degrees. If you draw a line from A to C, this arc, why will this angle be COC? What will be that angle? That angle won't be 60 degrees, isn't it?
So, but will it be equal to arc BC?
RKC is the length. So basically, what is the shortest path you want to find? RKC, right? Now here my question is, what will be the angle between AOC? What will be that angle AOC?
So 120.
Why it is 120? How did you prove that? How did you prove that angle AOC is 120?
So
Adrit, I
we,
can't see your camera. Your camera is totally blank.
so we add, right, AOB and BOC.
AOB is 60, BOC is 60, AOC is not 120. Both the angles are perpendicular, boss.
Sir, I'm changing the device now, so it may be off for 2-3 minutes after that.
ठीक है. हाँ Abhinav, AOB is in the horizontal plane, na? BOC is in the vertical plane. How are you adding them? Are you getting this, everyone? My question is, what is the angle AOC?
Is it 90 degrees?
No, Ray. Again, I'll tell you, see, we are not an astrology class. Don't guess. You guys need to give me a solid proof. Let's not guess answers. That's think. See, use your knowledge, think and get a wrong answer. That is acceptable, but don't just throw answers in the air. Because what will happen, right? You will make this a habit in the exam also. In a hurry, you will start guessing and you'll get wrong answers. What is the angle AOC? I hope everyone is getting it. What I'm asking. Aditya, Vidyut? Venkatesh, Palaksh? Abhinav, got your mistake, na? You can't add them directly.
Yes, so I got it. It's 3D.
Yeah, it's a 3D angle, na? AOB alag tha, BOC alag tha actually. You can't say AOC, you'll directly add them up. Now, one thing, see, I'll tell you how. If you take this thing, tell me one thing, this A and C will be on a circle, right? Everyone agrees that AC arc is a circle. So if you make a circle like this, somewhere here this will be A, somewhere here this will be C, and this will be some angle alpha. Isn't this the angle? Fair enough. And do you remember this thing? What is this length AC? How do you find that length? Drop the perpendicular, no? This angle will be alpha by 2. Remember this? We did something like this.
Yes.
Alpha by 2 and alpha by 2. So what will be AC here? We'll have AC is equal to 2 times R sine alpha by 2. How did I get that? If I take this point as D, in triangle OAD, sine alpha by 2 will be opposite side AD by OA. So AD will be R sine alpha by 2. And therefore AC will be AD plus DC, which is nothing but 2 times R sine alpha by 2. It is symmetry. Is this clear, everyone? And we proved it in the last class. What is AC length? Isn't this what we proved AC length as? Root over 3 by 2r. So this length is actually equal to root over 3 by 2 r. R will cancel. You end up with sine alpha by 2 is equal to root over 3 by 2 ka half, which is root 3 by 8. And you get alpha by 2 is equal to sine inverse. So this is how you can write angles. You can send the sine that side. Root over 3 by 8. So alpha will be 2 times sine inverse root over 3 by 8. So it's not a good angle. It is something else totally. It is not 120. It is not 90. It is something else.
So when sine goes to the other side, it'll become sine inverse, right?
Yeah, we can write that as sine inverse. So for example, we know normally, let's say sine theta is equal to half. We know theta is 60 degrees now. You can write this as sine inverse half, which is 60 degrees or 30. Making sense? So alpha you got. So what is the arc length now? So arc AC will be R into alpha, na? Isn't that the arc length here? Arc AC. You're done. So that will be 2 times R sine inverse root over 3 by 8. That's your answer. So you can't get that alpha directly by adding. You have to resort to, this way of calculation.
So can you tell how did we get AC equals 2r sine alpha by 2?
AC is equal to, yeah, I think last class, did we do? Let me show you. Here, we did this thing, no? If you're making an isosceles triangle, L and L sine theta by 2, L sine theta by 2, 2L sine theta by 2.
Yeah, okay.
No? For an isosceles triangle, when you drop a perpendicular, it becomes 90 degrees and you get half of angles. No?
So
I hope
if
all
you-
sure with this thing.
So to find the length of the arc, you have to multiply the radius with the
Radius into that
subtended.
angle subtended, right?
Okay.
So problem is getting that angle was a big headache actually. You're getting it. To get that angle, we need to find that length of the line AC. From there, you have to get the angle and then you can multiply with radius to get the arc length. That's where it is a tough one. So 3-dimensional, when you measure angles, right, you can't just add them. It is little on a different type. Have a look at this. Ask me if you're confused. All clear with this? Did you guys see the sheets which I sent you? There are 3 sheets. One is only trigonometry, one is different things. End of the class, we'll discuss them if you have any doubts. But I hope everyone tried them.
Yes.
Yes, sir.
Yeah. Clear? Can I go ahead?
So one.
Yeah. So if you look at this question, right, the steps involved, first we need to find the coordinates. Then we found the length of AC. From AC, we found the angle alpha. From alpha, we found the arc length. If you technically see, isn't it a pure maths question actually? We just said aeroplane is flying, but end of the day, it is all maths only. Then. Basic geometry. Clear? No. Go ahead. We are starting off with vectors today. So vectors, right? So before going ahead, we define something called a physical quantity. What's a physical quantity? Any quantity that can be measured and observed in an experiment. a simple definition. Anything that you can measure and anything that you can observe an experiment, we call it a physical quantity. Example, speed, power, work, energy, anything. You can just keep on taking current. So all these are physical quantities which you can measure. Now, there are also, things called non-physical quantities. For example, fear, hunger. If you see these kind of things, now, see one thing. The problem here is you can observe them. Tell me one thing. Are you scared of a snake? You're not scared of snake. If I throw a snake in front of you, you don't get scared. Okay. Vidyut doesn't get scared. So what if I throw a scorpion in front of you? Maybe you're scared, right? Now the question is, chalo, you're scared, so I can observe that. Can you tell me by how many times the fear due to snake is greater than fear due to the scorpion? Can you give me that thing? By what ratio the fear due to snake is more than fear due to a scorpion? A wild dog scares you. A snake also scares you. Can you give me the factor by which the snake scares you more than the dog? Can you see the problem there? You can observe fear in an experiment. You can't measure it. So we won't in science, right? We won't be studying such quantities. So any quantity that you can measure and you can observe, that's what we call as physical quantities. So physical quantities are of three types. So physical quantities, right? You can classify are of three types: scalar, vectors, and tensors. Now tensors is not there in our portion. We'll not be studying about it, but I'll just give a little brief what it is exactly. So first thing, if you talk about scalars, so these quantities, right, do not require any direction thing. It's something which can define only with a magnitude. A quantity which can be defined just with a magnitude. So it's like, mass of a body, 2 kg, right? Something like that. Distance, it's a scalar quantity. You just need a magnitude to define them. Distance, mass. So there is no meaning, right? Saying a mass which is in the direction of north, a mass which is in the direction of south. It doesn't matter like which direction the mass is. Mass is mass only. So such kind of quantities are called scalar. Clear enough with this page? Go ahead. Just a definitions, nothing there. And then anytime you feel like there is something on the page, right? You just stop me. If it is little theory, while explaining, I'll just go ahead because if you say I'm explaining slowly only, so there's nothing there. Anyway, you'll get the PDF end of the class. So let's focus more on thinking and figuring out what's happening. What is a vector? Now, if you look at here, you will see something interesting here. This is one thing which you see a lot in sciences. A quantity which has magnitude, fair enough, direction, and obey vector laws. Example, force. Force has a direction. Which way you're applying the force matters. Velocity, etc. So if you observe something right here, did you see what is the weird thing about the definition? What is a vector? A quantity which has magnitude, direction, and obeys vector laws. So in order to define what is a vector, you have to use the concept of vector laws. These kind of definitions are called circular definitions. Basically, what you're doing now, you're explaining one English word with more English words. You know how heat is defined? Heat is a quantity which will flow from high temperature to low temperature. What is temperature? Temperature is a property which decides the direction of heat flow. You're getting it? You can't explain it. You always use one definition in order to explain, the other definition. Like I'm saying, it is simply you're using more English words to explain English word. For example, tomorrow, if a first standard kid comes to you and asks you what is force, How do you explain him? What will you say? A force is something which will make you move. First standard kid, you won't get an understanding what you're talking. What is the best thing to do? Just kick him and call that as force. You'll understand very fast. So if you see, right, certain definitions, it is very difficult. For example, does everyone know what is momentum? What is momentum?
Mass
Mass
times
into velocity.
Now see, you know momentum is mass into velocity. Do you know what the hell it means? Dono alag hai. You know momentum is m into v. Great. What does it mean? Remember this thing. Not only in science, not only in physics, in life also, there'll be always two definitions. A technical definition from the textbook, a definition for you to understand actually what it means. Let me give an example. How do I explain this? Momentum. For example, let's say, if something is going with a speed of 1 centimeter per second, can you stop it? Just say, what do you think? Yes, no, right?
Yes.
If something has a mass of 1 gram, can you stop it?
Yes.
So if your local train is going with a speed of 1 centimeter per second, you'll stand in front of it. If a bullet of 1 gram goes with 1 kilometer per second, will you stand in front of it? What happens suddenly? Just now, 1 minute back, all are pretty confident. 1 centimeter per second, we will stop. 1 gram, we will stop. What scared you suddenly?
So that more momentum.
When I said 1 centimeter per second, mass was large. When I said 1 gram, speed was large. So you're actually getting scared of what? You're not getting scared of speed. You're getting scared of the product mass into velocity. Isn't it? So next time when someone asks you this question, can you stop it? You should ask, sir, what is the momentum? So momentum ka meaning is higher the momentum, more difficult to stop the body. Now, does that make sense? Now, this is not any textbook definition, but that is what it means physically. If a system has a high momentum, it is going to be more difficult to stop it from moving. Is that clear? Rehan, can you adjust your cam? I can't see you. Rehan?
Yes, sir.
Not Mehan, Rehan. I think he's sleeping, I guess. Okay. Palak, you need to adjust your cam. Do something. Your background all is hazy and it looks like you're living in some foggy mountainous area. No, it's fine. There is one of your senior who has a background of some alien Pluto types. So whenever he comes to the class, it feels like an alien has come to the class. So let's see. Yeah. Now, so look at the definition. So quantity which has magnitude, direction, and obey vector laws of addition. So what is the meaning of that exactly? For example, if you take current has both magnitude and direction. So if I give something like this, let's say 5 amperes current is coming from here, 5 amperes current is coming from here. How much current will go from here?
0.
Yeah.
10.
10
sorry, 10,
amperes,
10.
10
Ah.
amperes, right? Now the same thing, if this had been 5 Newton's force and 5 Newton's force, what is the total force?
So 0.
0.
Right? Force cancels out, but the current is not cancelling out, right? So even though current has magnitude and direction, current does not obey vector laws. This is the meaning of it. Right? Therefore, current is not a vector, it's a scalar. Are you getting this? So that is the thing. So if you just say magnitude and direction, it will become a wrong definition because it has to obey the vector law. So when you're adding them, if in technically speaking, 5 and 5 should cancel out, but they're not. Clear? Next thing. Similarly, if you see, can I turn the page?
So if a current is flowing in one direction, how do you
Hmm.
know that the current is flowing in the other direction?
What do you mean by that?
So if the current is flowing from right to left and
Okay.
the other current is the other one is flowing from left,
No,
how do
it can
we,
flow. It doesn't matter. You can flow any way you want.
so we express both as 2 ampere only?
I'll just change the numbers. No, this is 5 and this is 2 ampere,
Yeah,
right? So this will be how much? 7 ampere, right?
yes,
But technically speaking, if you're opposite shouldn't, if it is the forces, it won't be the same, right? It will cancel out, isn't it?
yes,
So that's what I'm saying. They don't. So current is not behaving like force, no.
yes,
So that's what I mean by vector loss. If you send current from both the opposite directions, so think of it like this, now, Abhinav. You're there. If I give you 100 rupees from this side, and if I give you 100 rupees from this side, you will have no money. That looks interesting, no? You'll have 200 rupees, right?
yes.
So that is what I mean to say. That doesn't obey vector loss. They just add up. The direction won't matter. On the other hand, area is a vector quantity. Now, this is little, people feel like, how can area be a vector quantity? Now, you need to understand something. My maths teacher, when we are taught this JEGA thing, I think it's in 2003 and 4. My maths teacher doesn't know vectors. Reason, vectors is a very recent topic, which was introduced somewhere in 1990s. Our maths teacher was quite old. When I was studying 11th and 12th, he's already 75. So vectors ka chapter, what happened, right? People were using concepts of vectors, but it was not defined as a particular chapter. So someone said, yeah, let's make this into a chapter. And so vectors is something which was created artificially. They made up all the concepts and they named it as a vector ka chapter. So you need to understand something. In physics or in science, when we do things because it is convenient. Are you getting it? Certain things we define because it is more convenient. For example, people realize defining area is more convenient than keeping it as a scalar. Example, let's say there is a room here and there is a door. Okay. Now let's say we have a computer there and which is trying to measure the number of people in the room. Now imagine if the area is a scalar quantity. If 2 people enter inside, what will the computer register as? +2. If 3 people come outside, what will the computer register? +3. Scalar quantity, right? Direction does not matter. So if people are going in, out, it will just keep on counting the numbers. So end of the day, what do you get? The total number of times persons cross the door, isn't it? Now imagine you're standing there and you're jumping inside and outside non-stop. What will happen? +1, +1, +1, +1, +1, +1, it will keep on counting, right? It's a useless data. But imagine area is a scalar quantity. Means you're defining outside is positive, inside is negative. Now, if 5 people enter inside, -5. 6 people come outside, +5. So what do you get in this case? The net number of people who enter the door, right? The data suddenly becomes useful. Are you getting this logic there? So people realized, that defining area is more convenient. So how do you define the area vector? More about this we will discuss later on. So if you have an area here, the area vector is defined as a vector perpendicular to the plane. So direction is given out of the plane. That is how we represent that. So for surfaces, area is perpendicular to the plane. So we define the area vector as perpendicular to the plane. So for closed surfaces, what do you mean by closed surface? Cube, sphere, these are all closed figures. For closed figures, outward normals are taken as positive. That is just a convention. So if you have a sphere like this, or if you have a cube like this, people consider this is positive. This is positive. Clear? So area is a vector quantity, current is not a vector quantity. So we define area as a vector quantity because it is convenient. This we will see a lot.
So why is it positive for closed figures?
See, for closed figures, we have something inside, outside, right? There are two directions.
Yeah.
So you have to take one as positive. So people just chose the outside as a positive. There is no logic there. It's like saying electron is a negative charge. Someone just said it is a negative and became negative.
Oh.
Rehan, you're there?
Yes, sir.
Yeah, you got disconnected, I guess.
Yes, sir.
Can you just adjust your camera a bit? I can't see your face completely. Yeah. Area vector, it is for a whole surface area, Maulika. For example, see, if it is curved here, so it's for the small part, ye area vector tha. For this small part, this is the area vector. You're getting? You take a small piece, and that for that you define one area vector. So technically speaking, for a sphere, there are infinite area vectors. It's like a ball of spikes. Able to visualize a ball with spikes? So the spikes look like that area vectors. Now, the representation of a vector. So how do you represent this vector? The first one is pictorial representation. You can represent it in three ways. One, you can represent with a diagram. So in this, what will happen? You show it with an arrow, the head and the body. The length of the body is proportional to magnitude. So bigger the arrow, bigger the vector. That is the meaning of it. The head represents the direction. That arrowhead which is there, that represents the direction. So simply, if someone says this is 2 newtons, so if you want to draw 4 newtons, it should be double the length. So this length will be double. So if you say 2 newtons is this, then 4 newtons should be double of it. 6 newtons should be 3 times of it. So it is just a reference. So that is one way to represent pictorially with a picture. Second thing is symbolic representation. You can use symbols to represent the vector. If you just say A, right, it's meaning scalar. So someone says like this, right? The mass of the body is A. If someone says A bar, meaning with an A, you keep an arrow on the top. This is how you pronounce A bar. Means I understood it's a vector quantity. So someone tells you like this, a body has a property A bar. Now the property can be anything. The moment you say A bar, I understood you're talking about a vector quantity. Right? If I say A cap, so this is how you pronounce this, A cap. The meaning of this is, it's a unit vector. What is a unit vector? A vector with a magnitude 1. A bar is just a vector. It can have any length. I don't know. You have to give me. But if you tell me unit vector, I know the meaning is it's a magnitude. Vector with magnitude 1. Right? So a unit vector, right? This actually gives the direction. For example, tell me one thing. If I say I'm walking 10 meters east, I'm walking which side? east, na? Now see, I'm walking, which way I'm walking? I'm walking east, na? Can I say this is 1 into east? So that is like, it's a vector of 1 magnitude, right? And direction is east. Are you getting the meaning of it? If I say I'm walking 1000 meters north, which way I'm walking?
North.
North. So I can write this as 1 meter into north. So it doesn't matter how much you travel. Unit vector is 1 only. So it gives you a direction. So if someone asks you find the direction of a vector, he is asking indirectly to find unit vector. Is that making sense?
Sir, can you go back for a minute?
I'll show. That is, if we want to find direction of a vector, you have to find unit vector. We'll see how to find that later on. Calculate unit vector. The last one, if I put mod a bar, this is pronounced as mod a bar. This is the magnitude of a vector. Basically, it's a scalar only. There, these are the 4 symbols, right? A bar, a cap, mod a bar. Have a look at this. Venkatesh, I think your screen is flickering, right? Or you're dancing so fast. Either way, you can keep your cam up for some time. A cap is just direction. It is both, right? Meaning, think of like this. A cap is like a vector. It's a vector with magnitude 1, which is also the direction of a vector, both. You're getting it? See, I can have a vector like this, not 2 meter east, 1 meter east, 100 meter east. All these are vectors. Among all this, the 1 into east is only direction, right? It has no magnitude, is only 1 single unit. Got it? So any vector with magnitude 1, we call it's the direction of a vector. We will see. We will do problems on that. We'll get the hang of it. All clear with this? Can I go ahead?
Yes, sir.
Then there's another way to represent this. If I write I cap, this is the meaning unit vector along x-axis. If I say j cap, this is a unit vector along y-axis. K cap, it's a unit vector along z-axis, right? Need this. Now see the reason, I'll tell you why you need this. So whenever you define something, we call it position vector. So there are different types of vectors. If the tail of the vector, so vector mein, this part is the tail. Head is that arrow, tail, and the body. If the tail of the vector is fixed at the origin, the head represents the position. Meaning, if I take a point P here, this is O here. So if you keep the tail here and head here, this is called OP bar. And let's say these coordinates are x, y. Now listen carefully. What is the meaning of this? Do you remember last class we discussed about coordinate system? What do you mean by x, y? What do you mean by x, y? It is an address, right? From origin, travel x units, and then from there travel y units. You get the point, isn't it? Isn't that the meaning of coordinate system x, y? So how do we represent this now? A vector, look at this. So we call it OP bar with an arrow. The meaning of this symbol is we are going from O to P. So the arrow is going from O to P. We are going from O to P. If I write PO bar, means you're going from P to O. So this is how we represent this. X into I cap plus Y into J cap. You know what is the meaning of this? Look at this. The meaning of this is I'm traveling X units along X-axis. I'm traveling Y units along Y-axis. Since we are lazy people, every time, you know, who will say X units along X, Y units along Y, I'll simply say X I cap plus Y J cap. So I cap and J cap ka, you know, meaning I understood. See, it is like this. If I say like this, I travel 10 meters east and 20 meters north. What do? You travel 10 meters and you travel 20 meters. Isn't this how you draw? So I can write this thing as 10 I cap plus 20 J cap. What is the meaning of this? From origin, I cap, matlab X-axis, walk 10 units. J cap, meaning Y-axis, walk 20 units. Are you getting the meaning of this?
Yes.
Is everyone getting the meaning of I cap, J cap, and K cap? So it is simply because we are lazy to say it every time. We simply say X-axis is I cap, Y-axis is J cap, and Z-axis is K cap. So that is the meaning of I, J, K. All clear with this? Next thing. Now, if I just take it to 3-dimensional, let's say this is point A, whose coordinates are A subscript X, A subscript Y, and A subscript Z. And this guy is O here. So how do we represent this vector? O to A bar means you're going from O to A. So you travel how much? AX along X-axis, that is I cap, AY along Y-axis, AZ along Z-axis. Is everyone clear with this? So simply, you know what is happening? X coordinate, Y coordinate, Z coordinate. Anyone has a doubt on this? Please ask me, get it clarified. Venkatesh, clear with this?
Yes, sir.
Rehan, Maulika, Yasha, clear?
Yes, sir.
Vidyut, clear, na? Now,
Yes, sir.
if I take OA bar, what is this? This is the length of the vector. Which is nothing but the distance formula, right? AX square plus AY square plus AZ square. So how do you find a unit vector? OA cap is a unit vector. So you take a vector and divide by its own magnitude. So you take OA bar and divide by its own magnitude. Think about it. If I'm going 20 meters east, what is the magnitude? 20, right? So if I divide this with 20, what happens? I get 1 east, na? Are you getting it? So if you take a vector and divide by its own magnitude, it becomes a unit vector. So this will become AX, I cap, AY, J cap plus AZ, K cap by root over AX square plus AY square plus AZ square. That's how you get a unit vector. Do check this out. OA bar, magnitude, and the unit vector. Put on a little basic theory, I know. We'll start doing problems here there. But you should be very clear with your basics. Anyone has any doubt on this page? Anything you're not clear, please ask.
So the magnitude can also be used, also be obtained using Pythagoras theorem, right?
We just have to use then like this, no, it goes.
Yeah.
You can do that. So you'll
Like
find that this
along
is one
X and
Pythagoras
along
and
Y.
this Pythagoras. You can do that.
Yeah.
I just kept distance because it is more easy for us to understand. Why to go into again this time.
Okay.
Clear? Go ahead.
Yes.
Now there is even more general thing. What if this is A and this is B? So you want to go from A to B. AX AY, AZ, BX, BY, BZ. So if someone asks you A, B bar, means you want to go from A to B bar. So you should take the final, that is BX minus initial AX, I cap. So you should take the X2 minus X1, final minus initial coordinate, BY minus AY, J cap, plus BZ minus AZ, K cap. In the previous case, this point was origin. So AX minus 0, AY minus 0, AZ minus 0. So this can be also written as, if you see, BX I cap, BY J cap, BZ K cap, minus AX I cap, AY J cap plus AZ K cap. That is nothing but O A bar and O B bar. So this turns out to be AB bar is nothing but OB bar minus OA bar. So B bar minus A bar will give you AB bar. And what about the magnitude of AB bar? Root over the X component, BX minus AX ka whole square, BY minus AY ka whole square. Basically, the difference in X, Y, Z coordinate, distance formula basically. Whenever they ask you magnitude, simply they're asking the distance formula, BZ minus AZ whole square. So if you're not starting from origin, this is what you have to use. Check it out. Ask me if there's any doubt on this. So I just extended it from origin, say, instead of you're going from A to B or something like that. Clear? Can we go ahead? So there, that is the representation of a vector and all that stuff. Basic. And I know today's class is a little basic, but don't worry. I think we will pump up the level slowly. Always make sure your basics are clear, and then high level problems will look better. If you're in a hurry, you'll always have a problem. Can I go ahead? Any doubts on this page? Maulika, clear, na? Adrit? Clear? Vidyut? Venkatesh? Palak?
Yes, sir.
Go ahead, na? Avinav? Swastika, clear, right?
Yes, sir.
Perfect. Let's see problem.
In the last page,
Uh-huh.
this one AB, how can we say that it's OB minus OA?
What is this thing? This is OB bar, no?
This, yes, OB.
This is OA bar, no? Just to be defined, if you have a point here from O to A, it is this. So if you have a point B here, that will be OB bar, no? BX, BY, BZ. Right? Adrit? Adrit?
Yes, sir.
Got it, no? And still you are confused, right? Let's discuss after the class. Again, telling you, you need not, say yes because I'm asking you 2 times. You can say, sir, I didn't understand. If I feel like it is too big to explain or if it's too confusing for you, let's sit after the class, but get it cleared. This is not school. No one will say if you didn't understand something. So we have points here. Let's call this thing. This is x-axis. This is y-axis. And this is z-axis. This is your origin. O. This is A. This is B. This is C. This is D. This is E. This is F. This is G. This center is H. And this thing is I. H is the phase center. This is a cube of side A. Each side of the cube is A. So find OH bar, DI cap, CF cap, EI cap. Let's get them. So we have a cube, OA, B, C, D, E, F, G, H, I. I is that center of that line, GB. Side of the cube is A. So indirectly what I'm asking now, find the coordinates of all these points. And then get OH bar, DI cap, CF cap, EI cap. Let's get them. Did everyone get the coordinates? How to get coordinates? Now see, I'll just tell you what to do. How to get the coordinates. If you're traveling along x-axis, which coordinate will increase? X. If you travel along y, y. If you travel along z, z. It's not simple. Now, when you travel from O to A, you're traveling in which direction? X-axis. So what will happen to the coordinate? How much did you travel? A, right? So A, comma 0, comma 0. Make sense? From A, if you travel towards B, in which way are you traveling? Z-axis. So remember, A coordinates already A, comma 0, comma 0. Now only Z is changing. So B will be A, comma 0, comma A. Is this making sense how I'm doing? Now from B, if I go up till I, I'm traveling in which direction? Y-axis. And how much did I travel?
A by 2.
Half of the length.
A
I
by
traveled half
A
of
by-
the length. Yeah. So A coordinates will be A, comma A by 2, comma A. If I continue traveling up to G, what will be G coordinates?
A, comma, A, comma.
A, comma A, comma A. Is everyone understanding how I'm doing this? Venkatesh, Maulika, is this clear?
Yes.
Rehan? Can you find the other coordinates also? Get them all. I'll give you a minute. And what do you need to find? OH bar, DI, CF. You need to find OH bar, DI cap, CF and EI. CF cap and EI cap. So that is how you can find coordinates of any point there. So it depends on how you're traveling. Everyone should find out the coordinates on your own. Try, I'll give you a minute and find those vectors. Vectors, you know, final coordinate minus initial coordinate, subtracted. You want unit vector, divide by its own magnitude. Next class is the most important one. Huh? We'll be doing something called resolving a vector. That is important. Literally every chapter in physics, mechanics, everywhere you'll see that vector resolution. In the entire chapter, if there's something which you should be very thorough with, it is the resolution of vector. Quite easy, not tough, but it's quite an important one. What about the remaining coordinates? Check your answers. So if I travel towards F from A, this guy will be A, comma 0. This guy will be 0, comma A, comma 0. H will be A, comma,
So,
A by 2, comma, A by 2. हाँ बोलो ना.
so it's 0 because it's traveling in the opposite direction, right?
Which one is that?
So the F1 is A, comma.
Because you're going in opposite of that, na? तो 0 हो
Yeah.
जाएगा. 0, comma, 0, comma, A, 0, comma, A, comma, A. Check your coordinates, everyone. Did I miss anything? Any coordinate you didn't get, you should ask me.
Sir, H is the midpoint of that side.
H is that, yeah, face center.
Okay, sir.
To find the vectors, we have to subtract using distance.
Subtract, na? So you're going OH bar, right? You're going from where to where? O to H.
Yes.
So final minus initial. So H is what? Final is A minus 0 I cap, A by 2 minus 0 J cap, plus A by 2 minus 0 K cap. Because 0 is initial, na? So that is A I cap plus A by 2 J cap plus A by 2 K cap. Make sense? So if you want DI bar, you're going from where to where? D to I. So I is the final, D is the initial. So this will be A minus 0 I cap, A by 2 minus A J cap, A minus A K cap. So this guy will be AI cap minus A by 2 J cap, and that is 0 K cap. So just don't write it. Making sense, Ajay? Right.
The first one, A minus 0 will be 0 minus A.
Yeah,
Final.
which we are talking OH bar, right?
Okay, I got it.
You are going from where to where? O to H. So who is final?
No, from D to I.
D to I. So who is final here?
I is final.
I is final, na? So this minus this, na? I minus D you should do. What is the magnitude of DI? Bar root over A square x component A by 2 whole square. That will be A into 4 plus 1 root 5 by 2. So what is DI cap? DI bar by mod DI. That will be A I cap minus A by 2 J cap by A into root 5 by 2. A cancels off. You end up with 2 by root 5 1 I cap minus J cap by 2. You can further simplify, but I hope you got the point. Check. So if I ask you unit vector, thoda you have to put little more work there. Find the vector, find the magnitude, and then divide them. What about the next one? You want to find CF and EI. Okay. So CF bar, you're going from F to C. So F minus C, A minus 0. I'm writing it directly now. A minus 0, A J cap. 0 minus A K cap. What is the magnitude of CF bar? Root over A square plus A square plus A square, A root 3. So what is CF cap? Divide them. A will cancel. I cap plus J cap minus K cap by root 3. Please check. If you don't get that, ask me. I'll show you in more detail, but I'm skipping steps now. And you want to find E I bar. So you're doing I minus E. That is A minus 0, A I cap, A by 2 minus this thing, minus A by 2, J minus E2 I na A K cap. The magnitude of this vector EI bar will be root over A square. So that is 1 plus 1 plus 1 by 4, 2 plus 1 by 4, root 9 by 2. That is 3A by root 2. So what is EI cap? I cap minus J cap by 2 plus K cap by 3 by root 2. Leave it there. Leave it. Check. Please check. Ask me if you're confused. Clear? Can I go ahead? Any doubts on this?
So one.
Anyone not clear with any particular step here or not convinced? So this is important, huh? Kubka, sides and all that stuff. Clear? Go ahead, Abhinav.
So can you just
Bastika?
repeat the value for DI cap?
DI cap देखो ना यहाँ पे.
Okay, so thank you.
All got the answers right? Perfect. Next one. We have a circle. This is your x-axis. This is your y-axis, and we have our favorite ant, which is going with speed u. And walks on circumference with speed u. R is a radius. Okay. Initially T0, you're here on the x-axis. So the ant will go on the circle, no? So after some time, the ant will come somewhere here, isn't it? What will be the position vector? This, right?
Yes.
When the ant comes here, this is the position vector. So position vector is changing, isn't it? Find the position vector after time t. Find the position vector of the ant after time t. So let's call the ant as A. So A is moving there. Find position vector OA bar after time t. Speed of the ant is given, radius of the circle is given. So here that A is the ant which is moving. The answer should come in terms of U, R, and time. So I'll just give you, let's say, ant comes here. Time t, this becomes point A. I'm asking you to find this guy. O A bar. Hope the question was clear. R I cap plus UT J cap. No, Ray Aditya, that doesn't work that way. That's not the answer. Just give it a try and just get some water and come. Yeah, any answers? All right. So first thing, the catch, you know what? If I know this angle, will my problem be solved? If I know that angle, this will be the x coordinate, this will be the y coordinate. I can find na x will be r cos theta, y will be r sin theta. Problem solved, right? How do you find the theta? Theta is not given. The problem is the theta. If I know the theta, I'll get x and y coordinates. Yeah,
So we
someone
can
is saying.
find the length of the arc, right? AX.
Perfect. From there you get
Which will
theta.
be-
That's it.
So
That's
I
it.
got the answer as r cos ut by r, comma r sin ut by r.
Yeah, that's the answer. See, in time t, how much will you travel?
UT.
This distance, na?
Yes, sir.
This will be u into t, right? That is the arc length. Speed into time, na? This angle is theta. So what is theta? Arc length by radius. That is the first definition we did. So theta is given by ut by r. So from here, drop a perpendicular. This will be r. This will be our x coordinate, and this will be y coordinate. So we get sine theta is y by r. So y coordinate is r sine theta. Cos theta is x by r. So you should remember this thing. Huh? We will not write this every time. Next time I'll directly say x is r cos theta, y is r sine theta. So the adjacent side will be cos and opposite side will be this thing. So what is the vector OA bar? So I got the coordinates here, x comma y. That would be x coordinate r cos theta. Theta is ut by r I cap r sine ut by r j cap. Check. The main catch is figuring out theta. After that, it is done. All clear with this? Any doubts on this? Clear? Next one.
Yes, sir.
Others? Adrit, Mehan, Maulika, Palaksh, Vidyut,
Yes, sir.
Yes, sir.
Swastika, clear, na?
Yes, sir.
Venkatesh, Abhinav,
Yes, sir.
perfect. Can I go ahead? Turn the page?
So
Yeah.
So basically we use distance formula for displacement vectors, right?
नहीं. यहाँ पे displacement vector will be what? This line, na?
Yeah.
That will be displacement vector.
Uh,
So for distances, meaning the arc length will be the distance only in this case.
okay.
If I had asked you displacement vector, you would have found these coordinates.
Yeah.
Initial to final. Yeah, that itself is another question though. Go ahead, Abhinav.
Yeah.
Yeah. Next one. I hope you remember this question. We have a wheel here. Radius r. Wheel of radius r is rolling on the floor without slipping. Do you remember what is the result? What was the result? What is the result of this thing? Wheel ka? Do you guys know this concept? What happens if a wheel completes one revolution? How much will it travel?
2 pi r distance.
Everyone knows that? Should I show you?
Yes.
So the catch is this thing. Say, suppose if I take a wheel here, this I think we did in the foundation. Some of you don't know. So listen, it's okay. So let's say this point is A, and this is B, and this is C, and this is D. Okay. So if I just paint these things with different colors, Getting it? Now, if I roll the wheel on the floor, what is the first color that you will see? Red, no? Then you will see the green. Then you will see that sky blue thing. And then you will see this. Oh, I don't know what color is this, but you'll come back here. So in one revolution, how much do you travel? One circumference, no? Is that clear, everyone? So in one revolution, the center of the wheel travels 2 pi r. One circumference. Is this clear, everyone? Malika, got this? Venkatesh? Right. So the actual question is this. So we have a wheel here. There is a point A here on the wheel. This point is origin on the ground. A is a point on the circumference of the wheel. Initially, it is touching the ground. So when the wheel starts rotating, the wheel becomes like this. And this point A comes here. Getting it? And this point is this point is exactly origin here. 0, 0. Find OA bar when wheel rotates by angle theta. You're getting it? The wheel is going like this. The wheel is rotating, going front and translating. So A will come up, right? So find the position vector of OA bar. Just to show you how it looks, listen, I'll just show you how it looks. So when the wheel is rotating, now this is what happens. Initially, A is somewhere here. A will come here, then A will come here, then A will go here, then A will come here. So what I'm asking you to find is this position vector. You're getting how is the position vector changing? The vector keeps on going up and down. The origin is fixed. The point A is going forward also, the point A is rotating also. So I want you to find this guy. When the wheel has rotated by an angle theta. So the wheel has gone forward and also the A has rotated. And this is the result which I have to use. In one revolution, you will travel a distance of 2 pi r. So how do you relate that? Give it a try. If you see, I'm teaching you how to find position vector only. But did you observe everything? Whatever I taught in basic maths is coming. That angle, that circle, all that stuff. So same thing. When I teach you calculus, vectors will come. When I teach you kinematics, everything will come. So as we go ahead in physics, right, the previous chapters will keep on piling up. That's what makes it interesting and yeah, a little tough also. But that is the fun part. That's if you see, right, people, most of the people in the top 5,000, they love physics. How do you find this? Indirectly, what I'm asking here, am I not asking X and Y coordinate of A? Right, Venkatesh? If I can find the coordinates of A, my job is done, right? How do you do this? Think for a minute. It's a good one.
Sir, I'm getting the X coordinate, but not the Y coordinate.
X coordinate, but not the Y coordinate. Let's see. Should I help you? First of all, did anyone figure out what is this length here?
So is
That's
it
the
2
arc
pi
length.
r by 4?
How much is that?
2 pi r by 4.
Pi r by 4. Why pi r by 4?
The 2 pi r by 4.
Why
Pi r
1/4? Why 1/4 of the circumference? Abhinav, did it go 1/4 of the revolution? How much is this length here? R
Pi
theta,
r
na?
theta.
That's the arc length.
It's the arc length, isn't it? Isn't it R theta?
Yeah.
Think about it. If you paint this as a black color and if I rotate it backward, wouldn't this be that color? Is that making sense? If I rotate it backward, meaning I know the diagram is not up to scale. So see, this is what happens actually. So if you take this point as A, from here to here, that will be same as this one. Does everyone agree with this statement here? This black line and this arc are equal.
Yes.
Anyone doesn't agree with that? Please ask. Malika, you agree with that? Venkatesh, Vidyut, Palaksh. So this angle is theta. So what will be this length here? R theta, na? So initially this was origin 0, 0. So this will be R theta, 0. Agreed? X-axis. Now from this triangle, I think I'll put that a little down. It looks better. I'll just put the center little up. I know diagram is not up to scale, but okay. So from here, if I drop a perpendicular, this is R. What will be this green line length? R sine theta. What will be this vertical line length? R cos theta. Everyone agrees?
Yes.
So what is Eka coordinates? R theta. You're getting, so you're going like this, R theta. You're going up and you're going left. So R theta minus R sine theta, comma, R cos R theta. Okay, it is R minus R cos theta. Because the circle also, no? That center I just drawn it little up. This length will be R minus R cos theta. Because the total height is R. Please check this coordinates X and Y. See, again, I'll just show you. This is R theta minus this. This will give you X coordinate, agreed? And this black line will give the Y coordinate, agreed? Clear na, Swastika? Yasha? Yeah, done. Question ho gaya na then. What do you want to find? Vector, right? OA bar. So OA bar is equal to R theta minus R sine theta. Remember this coordinates, huh? We are going to use this again in kinematics. There I'll ask you find the distance traveled by A. R minus R cos theta J cap. That is the coordinates of A. So as the wheel rotates more and more, the coordinates will change appropriately. Please ask, anyone confused here? So the first main catch in this point is to figure out that the length of this line is equal to length of this black line, this arc. Once you got that, you can find this X and Y and finish it off. Clear this. Any doubts on this? Clear? Can I turn the page? Next one. Let's do a little easy one. We have a vector OA bar, which is also called as A bar, because we are lazy people who will write OA bar, we'll call it A bar, which is 2i minus 3j plus 4k. Then what happened? Someone took this vector and rotated it. vector A bar is rotated by angle theta. How much is theta? They didn't mention anything. And when you rotate the vector, it becomes B bar. So OB bar, which is same as B bar, this is a I cap plus xj cap plus 2k cap. Find x. So you have a vector OA bar 2i minus 3j plus 4k. You rotated the vector by angle theta and it became OB bar I plus xj plus 2k. Then what is that x? Theta is not given, the value is not given. Any answers? How do you do this thing? Think I'll give you a minute. Anyone? What are the concepts here? I cap, J cap. Marika, I'm asking x ka value, right? Yeah, x ka value. What is that x? I plus xj plus 2k. What is that x? 1. What is the idea here? Anyone? What is happening?
So
How do you
10
handle
by
this?
3.
Mehan?
10 by 3.
Okay, what did you do? What is the concept?
Sir, like first 2 into 1 plus like that I
Nah.
equated it with 0.
Nah, why will you do that? Always see, again, I'm telling you, don't be in a hurry to get an answer. The process is more important. Always, when you see a question, try to figure out what the hell is happening. Then you jump to the question solving. See, that's how you learn step by step. If you're in a hurry to get an answer, you'll always miss the process. Tell me one thing, listen. If I have a vector OA bar, and if you rotate the vector to OB bar, what remains constant? What remains constant?
Sir, the vector B.
So then we can do
One
the
of the
triangular vector
coordinates.
addition.
0,
Ha,
0.
Arjun?
So the 0, 0, the coordinates, right?
Nah. What else remains constant? Chalo, I'll
Vector
ask you this
BA.
thing. Your hand is there. If you stretch your hand and rotate your hand, what will remain for your hand? What remains constant for your hand?
The length.
The length.
So,
So when you rotate a vector, right? Magnitude of the vector. Magnitude of the vector does not change by rotating. Magnitude of the vector does not change by rotating. Rotate how much ever you want. कुछ फर्क नहीं पड़ेगा. That means magnitude of OA bar should be equal to magnitude of OB bar. That makes sense?
Yes.
That is the concept. Getting it, Mahan? So magnitude of OA bar कितना होगा? Root over 2 square, 3 square, 4 square will be root over 1 square, x square, 2 square. Open this. This is root 29. So 29, and that will be 5 plus x square, no? So x square is 24. Yeah, x will be plus or minus 2 root 6. There are two answers. Easy concept, but the idea is that. So when you rotate a vector, the magnitude does not change. So you can equate the magnitudes. You can't do anything with the theta. Check. All clear with this? That's what I'm saying. When you see a question, right, don't jump into solving. First think, take a minute, figure out what is happening, what data is given, how can you interpret that data, and then you go ahead. Clear? Next one. Then we define something called parallel vectors. Now, there are different types of vectors. The first thing is parallel vectors. What are parallel vectors? Vectors with the same direction. So if you have vector a bar and if you have a vector b bar, so as long as the direction is same, they're parallel. So you can write a bar is k times b bar. If k is positive, we call them parallel vectors because they're in the same direction. If k is negative, we call them anti-parallel vectors because both will be opposite then. Example, if you say a bar, let's say if I say a bar is minus 3i and b bar is 6 or let's say 23i cap, direction magnitude doesn't matter. Clear? So that way, opposite of this. So whenever you get a parallel vector, you can take the relation a bar is equal to kb bar. Clear with this? So if the a bar is plus positive constant into b bar, it's a parallel vector. Negative constant, it's an anti-parallel vector. So now, if I give you something like this, we have two vectors, a bar, which is 2i plus xj minus 3k, and b bar is 4i plus 1j plus yk. If a bar and b bar are parallel vectors, find x and y. A bar and b bar are parallel vector 2i plus xj minus 3k and 4i plus j plus yk. Find x and y.
X equal to 2 and y equal to minus 6.
Okay, let's see. Try everyone. Easy one, it's a given. Easy one.
So that's one y cap over b.
One y cap, one j cap.
Okay.
2i plus xj minus 3k, 4i plus 1j plus yk. Find x and y. Just check your answers once. Remember, if two vectors are parallel, what is the relation? A bar is equal to kb bar. K is some constant. Try, I'll give you a minute. X is 2 and y is minus 6. Okay, let's see. Anyone else got that? Any answers? Anyone else? X2 C none. What is the condition? A bar is k times b bar. So 2i plus x times j cap minus 3 times k cap will be k times 4i plus j plus yk. So I can just multiply this and this will become 4k I cap, k j cap, and ky k cap. So shouldn't you, the x coordinates and y coordinates should be same. So 4k should be equal to 2. So k is equal to half. X should be equal to k. So x is equal to half. Minus 3 should be equal to ky. K is how much? Half. So y is equal to minus 6. हो गया ना? So x is half and y is minus 6. Check. So after multiplying by k, you have to equate the x coordinate should be same, y coordinate should be same, the z coordinate should be same. That is the meaning of parallel vectors. Your I ka coefficient, j ka coefficient, and z ka coefficient should be same. Easy. Check this out, everyone. All clear with this? Now, can I turn the page? Adrit, got your mistake?
Yes.
Abhinav. Abhinav, go on.
Now will the vector B also be equal to A into K?
But वो क्या अलग होगा ना? That will be 1 by k actually. You can write like, if you write b is equal to k a bar, your k will come out to be 2.
Okay.
We should write as k dash.
Okay.
So don't take the same variable. You can take it as k dash. That k dash will come out to be 2.
Okay.
So we just put a note. So a vector, right, does not change by shifting it parallel to itself. Or along itself. Meaning, if you take a vector like this a bar, if you push it forward, it is still a bar. If you push it backward, it is still a bar. If you push it parallel to itself, it is still a bar. This is still a bar. So you're getting it. So you can't change that. But it changes when we rotate. So if you rotate a vector, it changes, but remember magnitude remains constant. Because the direction changes. So if you want to change a vector, you have to rotate it or stretch it. But if you rotate it, the magnitude won't change. So you can change a vector by only changing direction. Clear? So there, that is some of them. So next class when we meet, right, we will do more of it. We will see, like, there are different types of vectors. There's something called a pseudo vector also. That is one thing we need to put a little work on. That we will do it in the next class. So next class when we will do that some of few types of vectors. And what do you call it? We'll do resolution of vectors. That is quite important. Okay, so with that, we'll wrap up for the day. So in the sheets or assignment, any doubts or today's class, any doubts you can ask me. I hope everyone tried. In case you didn't try, I think you can try and next Wednesday you can ask me, but make sure to finish all the sheets. But anyone has any doubts in those sheets, you can ask me. If I hope at least everyone tried one sheet.
Yeah, I had it out.
I have
Right?
doubt.
So let's see the one sheet. I should have named them. No? Any doubts in the trigonometric sheet?
Yes, sir.
Did everyone try? Did everyone try?
Yes, sir. I had it out. So
Let's see. Let's go in an order, okay? The trigonometric sheet. Any doubts in that?
So the seventh one.
Seventh one, actually, you need a formula. Tan A plus B. Pata hona chahiye tha actually. We generally don't use this much in physics, but in this case, you need it. This is the formula we have to use. So what is happening here? If you read the diagram, you have this, and you have a flag, na? he's saying this angle is there, right? Let's call this alpha. The tan alpha is 1/9. Right, Abhinav?
Yes, sir.
This is 80 meter and this is 100 meter. Okay, and this angle is theta, na? So tan theta is how much? 80/100. And let this be x, na? The flag post. So tan theta plus alpha will be 80 plus x/100. So you can find tan theta plus alpha from this formula and then put it here and you can extra formula.
Okay.
You'll try now. I will leave it there. Give it a try. If you're not getting, let me know next class. Anything else in this Trigo sheet?
Yes, sir. In question number 4.
Question number 4. If you look at the diagram, na, it is think of it like this. You have a flag staff and you're saying from here the distance is same. The distance. Equal angles, right? Maulika, so what does it mean? If this is alpha, this is h. He's saying this distance is same, right? Now tell me, where will all these points be? On a circle, no? You take any point on the circle, won't this distance be same? Right? Maulika?
Yes.
Who asked it? Swastika. Huh.
Swastika,
So if you join these points here, what kind of quadrilateral is that? Cyclic quadrilateral, right?
Okay, sir. Yeah, I understand.
That is a, yeah, if your quadrilateral is on a circle, the 4 points, it's called a cyclic quadrilateral.
Yes. Yes, sir. Thank you.
Right? Others, if you have not tried, again, I'm telling you, finish it off. Next week also you can ask. So if you don't have any doubts, you're free to leave. Those who have doubts, you can ask, continue. But make sure to finish off next time, right? Be on time. Don't delay it like this. Right? So those who have doubts, you stay back and ask, others can leave. Haan, Yasha?
In basic maths assignment, the second question I have.
We will go. Is it all clear in the Trigo sheet?
Sir,
So
12.
the last question, 12th one.
12th one. Tower height, 4 corners. Diagram ऐसा है ना? This is the tower, right? So you're asking this, no? What will be this side? A by root 2, no?
Yes.
हो गया ना? What is cot alpha? A by root 2 by h. Substitute, they will get the answer.
Okay.
Understood? How is that? From the center, you put it and that will be half diagonal and that is height h. From there, you get cot alpha and substitute in that thing which is given. Anything else in the Trigo sheet? Clear? Then the basic.
Sir, in
which
the
one?
sir, in the 12th question, I'm getting different answer, which is not in the options.
You're doing
1 by 2.
You're doing calculation mistake. Check it out properly. You're doing calculation error. Yasha, which one is this? The infinite GP wala or the other basic maths?
Other one.
Okay, that circle, blue, red wala.
Yes.
Okay. Which one?
The second one, the circle.
Circles, marble.
Ah.
Marble one, na? See. You just take, okay, 2 ones, okay? If you take 2 of them, when you draw a line like this will be a tangent, agreed?
Yes, sir.
So this will be a kind of like a cone, no? And from here, if you drop a perpendicular, this will be 90. This will be 90, agreed?
Yes.
So if this is B and this is A and that is theta, right? And this also will be A and this also will be B.
Yes.
So when you, and this length is there, I don't know what is this, let's call it X. Okay? So from there I can find what? So what is sine theta here? A by X. Right? This triangle. Right, Yasha?
Yes.
Similarly, sine theta big triangle. इसमें क्या होगा? B by X plus A plus B. Okay. Now from these two, if you can eliminate X, you will get a relation. B by A is a constant.
So in the first one, will it be sine theta A upon X plus A?
नहीं ना, only this much triangle ना रे center से, right? You're taking only till here ना?
Sir, उसमें भी तो radius आएगा ना उसका.
Where?
We are taking whole as.
Okay, okay. I actually took x from here to the center.
Okay, sir.
Okay. Or if you want to take from here, when you're saying take x from here to here, बोल रहे हो.
Yeah.
Yeah, fair enough. Meaning it depends on how you want to take that. I took x from here.
Okay, sir.
Okay. So start from here, Yasha. When you do this thing, na, you'll observe, you know, that b by a, you will get a factor. So you'll observe, you know what? Every time you put one more ball here, it will increase by a factor of this constant. It actually forms an infinite. It's a GP. It forms a GP. So
Okay.
try to prove that. I'll show you in the next class if you're not getting. So answer kaisa aayega na? If you take this 5 of them, if this is a A and this is a B, the center one will be root AB, geometric mean aayega.
Okay.
Try to prove that. So basically from the angles you will get, meaning kaisa hoga na radius? Let's say if this is some x, this will be kx, this will be k square x, this will be k cube x, this will be k power 4x. It will always multiply by a factor of k, which is some constant.
Okay, sir.
I think try to see from here. It's a good one, but nahi aaya to let me know. Next class I'll discuss it. Like I said, see, it is most important you take hints and you try again. It's not about giving an answer. What else? If you're done, you can leave anytime. Those who have not, stay back and ask. Anything else in this sheet?
Sir, the 8th one, basic maths assignment.
Third question.
6 trees wala. 6 trees are planted, that one?
Yes, sir, yes.
Kya
Sir,
hua
there
isme?
are two cases. मतलब दोनों answer possible है, 720 or 820.
But you have to find the minimum distance, no? Read the second line. Minimum distance is asking, no? So among the two cases, find the minimum. Palak.
Sir, but here the answer in the answer key is 820.
Okay. Okay. That might be. How much you are getting? 720.
And 820. Sir, both cases are possible.
Okay, then that must be everyone got 720 for that. It's one. Anyone else got 720 for that? Adrit?
Yes,
Eight.
sir.
720 कैसा है बताओ रे एक बार. Palak, how did you get 720? How did
Sir,
you start?
Yes. Sir, first he will travel to the last key, then he will cover the double distance because he has to get water and
Yeah, so he will
then-
travel where? 20, 20,
then he
20,
will
na?
do the
So from
same
here,
like till the second tree.
how much is this? 120?
Yes.
120, then
Then from 5
100.
to yes, double.
100,
Then-
then
4.
80, 80,
Yes.
then 60, 60, 40, 40, and then 20, na? Done.
Yes, but sir, yes, only single time 20.
You won't come back, no? Pani
Yes.
to ho gaya plant tag. So add this, how much you're getting? 720 or 820? How much is this? 140, 140 into 6, 14, 3, 40, 40, 840, 820 आ रहा है रे. So check, I'm getting 820 only. Maybe I am doing a mistake or you're doing a mistake. What else?
So if he travels like from the first well to the first tree and then the second, third, fourth, fifth, then I think that will come separate.
Actually, yeah, that will be a better idea because last में
Yes,
वो
that will be
वापस
the
आने का
shortest
जरूरत
distance.
नहीं था. Actually, हाँ रे, that is the shortest distance. Don't travel like this. You travel 20, last 120 travel मत करो.
Yeah, last one to 8.
Don't travel the last 120. You go
Yeah.
like this. And the last one you don't come back actually. I think then you'll
So,
get 720.
Yeah, that will be 720.
The actual answer is wrong. The eighth ka answer is B. That was a mistake. I'll change that. That's a mistake. Don't go to 6 first. Go to 1. Palakshi, that's what you got.
Yes, sir.
Yeah. What else?
So I had a doubt in the infinite GP sheet.
करते हैं. ये sheet खत्म हो गया सबका basic maths assignment, the balls thing.
The
Sir,
third one.
Adrit?
third question.
Third. A man goes out for a walk. He walks south 1 mile, east 1 mile, north 1 mile, and ends up. He is not in the North Pole, where it is in the South Pole, no? Is in the South Pole. Because see, pole is a special point, huh? When you're on the South Pole, if you walk, he walks 1 mile. Okay, then start at the North Pole. No, South Pole bhi nahi hoga. You walk south 1 mile, east 1 mile, and north 1 mile. Okay. No, this is not that way. He must be pretty close to South Pole somewhere. See, this is south, no? If you're here, you travel to South Pole, right? And then you travel east 1 mile. Now from South Pole, no matter which way you go, and then how you're traveling again, and you're traveling north again. Actually, South Pole mein east is not defined. Eliminate that option. Wait, let me see this thing. Okay, and then east 1 mile and north 1 mile. North Pole, so that was one possible answer. South Pole mein start kiya to from South Pole you can't go south anymore. Basically, you're going in 3 dimensions. You have to be careful with that. Anyone figure this out? Let's see, what is this? So if you start somewhere here, you go here, South Pole, now you're going east. Actually, once you're at the South Pole, right, there is no east only. Everything is north only for you. You're not going to the South Pole also. That was a mistake. Nice, right? This thing, how did we do this last time then? If you're at the equator, if you go down south, and if you go east, and if you try to go north, you'll reach here. So that is also gone. I thought it was South Pole, but then anyone got this? Adrit, what did you think?
I first thought of South Pole and then I
Maybe South Pole actually, and I gave this even I thought South Pole, but when from South Pole you can't go south anymore, na?
And I found no other possible answer than North Pole.
Yeah. You travel south and then you travel east and then you travel north. Acha, chalo, let me think about it. Anyone figure out, let me know in the next class. What else?
Look, I had a doubt in the infinite Rubik's cube.
Adrit,
I got to doubt in 5th question.
bird flies wala.
Yes. Bird
That's a
and
good one, right? You're not there for the foundation?
No.
Dekho na, in how much time will the car go and hit the wall? 40 by 8, 5 hours, right? So for 5 hours, what is the bird doing? It is flying non-stop. So what's the distance traveled by the bird? Speed into 10 into 5, 50 kilometers. You get the point?
Okay,
The bird will keep on flying till the car hits the wall. That takes 5 hours. So 5 hours, what is the bird doing? Flying non-stop, no? So what's the distance travel? Speed into time. Right?
Okay.
Yeah. Abhinav? Which one?
I had a doubt in the infinite Rubik's cube.
Which one?
So the 4th one.
Okay. This thing we did something. Now see here what happens. A is here, no? Initially, after half revolution, where will you be? You will go front, and A will come here, isn't it? From here to here, what is the distance? Pi r
Yes.
plus r, no? That's the displacement, right?
Okay, understood.
Got it? Then anything else from any sheet?
Last question in the basic maths.
The hexagon wala?
No, not that one. Other sheet.
Yeah, the last question. Sam used to walk to school every morning. It takes 20
I'm
minutes.
getting 12 by 20, but the answer is 9 by 20.
9 by 20. Acha question tha. Can you send me a working later on? Whatever you did, na, अच्छे से एक working करके, whatever you did, mistake or something, send me. I'll tell you where you're going wrong. That's a good one. What else? Done? Chalo, you guys can leave. Anyone else, stay back and ask. Or else you can leave. Adit, try that. Try that with the working and send me. I'll tell you what mistake you're doing in the next class. That is
Okay,
always important. If you're still not getting, I'll explain you. That's a pretty good one.
So
Chalo then. Ha, Abhinav.
the three-dimensional polar coordinates, I tried drawing it back again in the house. I did not understand. Like I was not getting it.
What exactly which part you're not getting? It is always about dividing that, na? See now, you're traveling like this, and then you're traveling like this, isn't it?
Yes.
So when you drop this perpendicular, ये z coordinate होगा,
Okay.
and ये angle phi है ना? So this will be what, r sin phi,
Yes.
and ये कितना होगा, r cos phi, और
Yeah.
ये theta. So this will be x and y ना? तो ये r cos phi का sin theta, ये r cos phi का cos theta.
So the y and x you've drawn is in the direction of x and y axis, right?
हाँ, in the direction of x and y axis.
Okay, so
ना? Check करो. If still confused, recording is there. You can watch that one part. You're still confused, ask in the next class.
Okay.
Swastika, anything more? Palak?
No, sir.
No, sir.
Chalo. Yeah.